$49.5 billion. Seriously, just take a second to let that number sink in. That is the massive financial scale the fleet EV charging market is projected to hit by 2035. The transition to electric commercial vehicles, it's not just some distant environmental goal anymore. It is an absolute economic explosion, and it's happening right in front of us.
But here's the massive roadblock staring down pretty much every fleet operator today. How do you actually power the future when the grid simply can't keep up? We've got this intense immediate pressure on companies to electrify their fleets, and it's colliding head-on with the painfully slow reality of utility grid upgrades. You can go out and buy the electric trucks today for sure, but getting the power to run them, well, that is a completely different story.
Welcome to The Explainer. Today, we're diving straight into decoding the fleet EV charging revolution. We're going to break down this massive shift from traditional permanent infrastructure to agile off-grid commercial solutions.
Here is our roadmap for The Explainer today. Number 1, the EV fleet boom. 2, the grid bottleneck. 3, enter charging as a service. 4, going off-grid. 5, real-world fleet solutions. And finally, 6, the future of fleet charging.
Section 1. The EV fleet boom, scaling the market.
The sheer velocity of this transition is absolutely staggering. We are looking at a market leaping from roughly $5 billion in 2024 to nearly $50 billion in 2035. That is a massive 23.12% compound annual growth rate. And, this isn't happening in a vacuum. It's being aggressively driven by corporate sustainability initiatives, companies actively trying to hit those net zero targets, and a desperate desire to escape volatile traditional fuel costs. The fastest growing segment inside all of this? Commercial vehicles. Heavy and medium-duty fleets are pushing really hard to electrify right now.
Section 2. The grid bottleneck, waiting on power.
This is where fleet managers are just hitting massive roadblocks. You order your brand new electric fleet, right? But then you're stuck facing up to an 18-month wait time just for the utility grid upgrades to get power to your depot. On top of waiting a year and a half, you're looking at heavy upfront capital expenditures for trenching and hardware. The reality is most existing depots just have insufficient power for even a few fast chargers. And hey, if you do get connected, you're looking at massive demand charge exposure if you happen to charge during peak evening hours. Finally, relying on slower level 2 charging severely limits your vehicle turnaround time. It's literally a logistical and financial nightmare.
Section 3. Enter charging as a service, the zero CapEx solution.
To fix this, we need a total paradigm shift, and that is charging as a service, or CaaS. It's a zero CapEx model. That means no massive upfront capital expenditures. The provider deploys, owns, and operates the infrastructure, and the fleets, they pay only for the energy delivered, kind of like a standard utility bill. This completely shifts the narrative from a hardware problem to a managed service solution. You remove the entire burden of buying the equipment, hiring the electricians, and managing all the ongoing maintenance.
When you actually put these two models head-to-head, the difference is night and day. Traditional grid charging means heavy upfront capital costs, sitting through that painful 18-month utility wait, and if your lease ends or you move sites, you're leaving behind permanent, stranded assets. In contrast, charging as a service offers zero upfront costs, deployments that can happen in literally 7 days, and infrastructure that is fully scalable and mobile. It lets fleets completely bypass years of waiting and heavy capital risk.
Out in the real world, a turnkey deployment looks exactly like this operation by a provider like InCharge Energy. The infrastructure is entirely managed by the provider. And what's truly fascinating about modern CaaS is the software backbone. Using their proprietary charge management software, providers can monitor these stations proactively and resolve over 75% of issues remotely. It lets fleet managers focus entirely on running their actual business, not on acting as amateur grid engineers.
The rollout process for this is incredibly streamlined. Step 1. Hardware is deployed, and get this, often with zero construction or trenching required. Step 2. Energy starts flowing, and you just pay a predictable rate per kilowatt hour. Step 3. AI steps in to intelligently optimize the load. It manages when and how the vehicle's charged to save costs and protect your uptime. And finally, Step 4. The provider maintains the whole system 24/7. If something breaks, it's on them to fix it.
Section 4. Going off-grid. Breaking utility reliance.
So what if the grid simply can't reach your depot at all? Or what if you only need power temporarily? The ultimate solution here is becoming islanded. An islanded system is basically a localized electrical grid that operates entirely independently from the main utility grid. We are seeing a huge, rapid rise in these islanded charging technologies because they offer complete resilience in power outages, and more importantly, they completely sever your reliance on utility upgrade timelines.
On-site, this level of independence is incredibly flexible. Providers can create a highly customized mix of local power generation, like rooftop solar, and pair it directly with heavy-duty battery energy storage systems. These massive batteries can bank energy during off-peak hours and then dispatch it at full power, right on demand, to your vehicles. It's localized, it's emission-free, and it guarantees maximum uptime for the fleet.
Depending on what a specific fleet needs, these off-grid assets come in some really flexible formats. The Massachusetts Clean Energy Center recently categorized these beautifully. You have palletized systems, which are basically semi-permanent platforms, skid-mounted units sitting on a single base that can be adapted with wheels, trailer-mounted units, which are highly relocatable across different distribution centers, and wheel-mounted units, which are compact enough to literally be moved by hand across a single yard. This means you bring the power directly to the parked vehicle, completely eliminating the headache of shuffling vehicles around a depot just to plug them in.
Section 5. Real-world fleet solutions, deploying in days. The absolute crucial point here is the speed of deployment. Take a look at this real-world case study. Epic Charging and L-Charge partnered up to set up an off-grid, hybrid charging site in a major metro area. The site had really heavy demand, but zero grid access. So instead of waiting months for permits and utility connections, they deployed ultra-fast off-grid chargers powered by low-carbon fuels in under one single week. The site became a fully functioning asset, serving both commercial fleets and everyday public drivers, generating revenue and cutting emissions from day one.
And you know, this brilliant off-grid model isn't just solving problems for last-mile delivery vans, though they definitely benefit from the rapid overnight turnaround. This grid-free power is unlocking electrification across entirely new industries. Think about autonomous vehicles that demand 24/7 runtimes anywhere they park. Modular data centers that deploy in 120 days and simply cannot wait 5 years for grid power. Massive ports and logistics hubs needing to move heavy cargo without grid capacity limits. Even remote, active construction sites. Power is now completely decentralized. It goes exactly where the work is.
Section 6. The future of fleet charging, scaling on demand.
Looking ahead to that nearly $50 billion market in 2035, the trajectory is all about flexibility and speed. The data shows our fastest-growing market segments are Level 3 charging, DC ultra-fast stations, commercial vehicles, and portable installations. Because heavy commercial vehicles are dominating the transition right now, the massive demand for Level 3 DC ultra-fast portable charging is going to lead the entire industry forward. The days of pouring permanent concrete and waiting years for copper wire, yeah, those are fading fast.
Which leaves us with this final provocative question. If you no longer have to wait years for the utility grid to catch up to your business goals, if you can deploy full-scale, intelligent off-grid power in literally a matter of days with zero upfront capital, is your fleet ready to ditch the pump today? Thanks so much for joining me for this explainer. I really hope this gave you a powerful new perspective on how to scale your operations moving forward.